My name is Kirk Lougheed. I'm the Senior Project Manager for Command and Control of Communications at Kennedy Space Center. My primary responsibility is the Project Manager for the Launch Control System, which is currently being deployed in Firing Room 1, where we are today. When the Constellation program was envisioned and the support requirements were being defined for Kennedy Space Center, it was noted that there was a requirement for a command and control system for ground processing of the launch vehicles and spacecraft for exploration. At that point, a trade study was kicked off to determine what kind of command and control system was needed. The trade study team looked at legacy systems already at Kennedy Space Center. They looked at commercially available systems used for some of the other launch campaigns across the center and the Air Force Base. And also we looked at what was called a standards-based architecture approach. What came out of that trade study was the standard-based architecture was selected. Now that meant that the design of the command and control system would rely heavily on commercial off-the-shelf hardware and software, COTS products. This introduced a risk into the ground operations support requirements of using COTS products in the closed-loop command and control system and having to go design to that in the presence of ambiguous ground operations requirements with respect to the launch vehicles and spacecraft. COTS came out strong in the trade study and using COTS in the manner that we're talking about because it allowed a significant leg up, if you will, for development and design. It also helped with our schedule and our labor costs. The idea is that we're relying on industry to provide capability that in the past had been developed from software written here at Kennedy Space Center and the previous command and control systems used for shuttle, for instance. So the COTS, using COTS represented a significant benefit for schedule and budget performance with respect to the overall project. So that was the strong feature that came out with respect to the trade study. We had to procure the COTS products early in the development phase for many reasons. One of them, we had to begin our design and we had to start evaluating these COTS products as soon as we could. This represented a risk to the architecture development team because they had to go procure these products without having all of what were considered essential requirements with respect to ground operation support requirements for the launch vehicle and spacecraft. So this was a quandary that the design team was put in to go and make some expenditures based upon some notional aspects of with respect to these requirements, and that's how the risk was manifested. When we looked at these COTS products and we performed our initial analysis on them and did some testing against it, as expected, not surprising that the COTS products performed slightly differently than what was advertised or slightly differently than what was envisioned when they were first procured. So this was a significant effort to determine if that was a detrimental aspect, i.e. it did not fit into the architecture, or was it okay in that the architecture had to go adapt to what the COTS products were doing. So there was a constant trade between where the architecture needed to go and what the commercial products had to provide. We had an overlying tenet that we would not try and change the performance of the COTS product. We would not expect to add any features or expect the vendor to provide anything different to Kennedy Space Center than they were providing any other customer that they had. So that meant a lot of times that we had to adapt what we were doing to how the COTS products performed and ensuring that we still met our ground operations support requirements. We had three primary risk mitigation steps. The first was to develop a performance test model of how these COTS were expected to perform with respect to the ground operation support requirements. Second is we had to procure a first set of these COTS products and test them with respect to this model that we had developed. Now, the model really focused on the closed-loop, real-time command and control capability. The third mitigation was probably the most important, is that the architectural team had to develop a model of the architecture that parsed out the performance requirements with respect to where they were needing to be applied. That is, the real-time closed-loop control would be more towards the front end, closest to the end item under test. That's where the short turnaround with respect to commands and measurements would have to be processed. At the other end of the spectrum, was where there was more emphasis placed upon situational awareness and human-in-the-loop command and control capability. That was where the traditional servers, displays, and workstations are, as what you see in the control room. So the architectural team developed this way to bucket, if you will, the support requirements where they were best supported, i.e. if you had something coming from the vehicles that required closed-loop, tight command and control, that was allocated to equipment, COTS products out at the front end of our system. Where they were requiring more of a human-in-the-loop, situational awareness, that was allocated to the requirements of the COTS products in the control room. So the ability to go ahead and provide these buckets for the requirement support was significant in that it allowed the development team to move forward to develop a command and control system architecture and system level design and software design, knowing that they had the margin to support requirements as they emerge depending upon their performance profile. The lessons learned that we got from this activity were very significant to Kennedy Space Center and the command and control capability. The first lesson learned is that the expectation that we'll have, that someone designing a ground system is going to have all of the required interface requirements for spacecraft available when they're needed, i.e. when during that critical phase of architecture definition, should not be considered. You should not count on that. So what has to happen then is you need to develop a way to develop an architecture in the presence of this ambiguity, in the presence of these missing requirements. Now that meant that you focused on the specifics and the infrastructure associated with command and control, leaving out, or waiting a while, I should say, until to define the actual interface definition, the actual interfaces that would meet with the interfaces from the spacecraft and the launch vehicles. So that lesson learned of not waiting for all the requirements to be provided was significant, because if we waited, we would have been late, and it would have represented significant risk to Kennedy Space Center ground operations support requirements being met. We weren't surprised by anything as the requirements emerged for the Ares and Orion spacecraft. The decisions that we made 2 to 3 years ago, relying upon, were sound decisions. We relied upon our architectural model, which proved itself, and such that we were able to go ahead with a full-blown design and development of the command and control system without really any significant hiccups with what we learned how the actual interfaces needed to work with Orion and Ares. The second lesson learned from this, and it kind of has become more evident as time has gone by, is that by using this approach for command and control, it has positioned Kennedy Space Center in such a way that as we see Constellation end and the new programs emerging, 21st Century Launch Complex, Heavy Lift, etc., we see that the command and control system is now positioned to support those new requirements, because it's the same kind of ambiguous environment that we've developed the system in, but it positions Kennedy Space Center in such a way that whatever vehicle emerges from or all the vehicles that emerge from the post-Constellation efforts can now be supported for ground operations at Kennedy Space Center using the launch control system. To contact me, my name is Kirk Lougheed. You can look up my name and email address in the global directory. I can also direct you to some of the system architects for further technical discussions if that's what you would like.